This is your reteach or test corrections for chapter 4 test. So the first section is making sure you know how to solve systems of equations. And you have to do the first one by graphing, the second one by substitution, and the third one by elimination. So the graphing one, I'm going to graph by hand here on the grid, but you could have used your graphing calculator as well. All right, so y equals 2x plus 3. That means I'm going to start at 3, 1, 2, 3, which is the y-intercept. And then I'm going to count the slope. The slope of 2 will go up 2 to the right 1, up 2 to the right 1, or down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. Okay, and I'm just going to keep going because you know when I try to draw this line, it may not be all that straight. So I want to know where all those points are. That does not look too terrible. All right, now the other one has a y-intercept of -2, and the slope is 1/3. So that means we're going to go up 1 to the right 3, up 1 to the right 3, or down 1 to the left 3, and right there is where they're going to cross over because that blue point went right on where the other point was. Okay, so my intersection is, let's see, this point right here. Okay, so a lot of you just left it like that. But if you're going to solve it, you need to say what the solution is. And the solution is an ordered pair. So you should have written down either your ordered pair, or you could have said x equals -3 and y equals -3. I didn't take points off, but just, be aware the solution isn't just draw a graph and expect the person reading it to know what the solution is. Okay, so next one says we must solve using substitution. Before that, going back to number 1, graphing would be the easiest method to use here because they're both solved for y. So you could, count it off like I did fairly easily if you know what the slope, how to count off the slope. Or you could grab your graphing calculator and get the answer that way. Number 2, however, if I wanted to solve by graphing, I'd have to solve the 2x plus 2y equals 22 for y, and I don't really want to do that. But I see that this equation here is already solved in terms of y, so that makes substitution a pretty doable thing here. I'm literally going to take this and put it in for y. Then I'll have an equation just in terms of x, so I can solve it and figure out what x equals. Okay, so I have 2x plus 2. Instead of y, I'm writing 2x minus 1 equals 22. Now it just looks like a multi-step equation that we solved back in September. So 2x plus 4x minus 2, don't forget to distribute, I had a couple people forget that, equals 22. Combine like terms. Oops, 22. Add 2 to both sides, divide by 6, and x equals 4. Once you have that, now you have to figure out what y equals. So x equals 4, I'm putting back into this equation, only because it's easier, I think, than doing 2x plus 2y. Y equals 2 times, well, x is 4, I said, so 4 minus 1. So y is 8 minus 1, which is 7. Okay, so you could have just left it y equals 7, x equals 4, or you could write the ordered pair as a solution, which would be 4, 7. Either way. All right, and then number 3, elimination, which happens to be my favorite, although these numbers are kind of icky. I wouldn't want to have to solve for y, because I'm reasonably sure 83 is not going to be divisible by 4, so that's going to give me a really icky y-intercept. You could do substitution, but again, it's kind of complicated. So I'm going to choose to do elimination. So with elimination, remember you are eliminating either the x's or the y's, a term. So it doesn't matter which one you choose. nor does it really matter how you eliminate them. I'm going to eliminate my y's, only because the first equation has a positive y and the second equation has a negative y, so I'm already like halfway to my zero pair. So if only those coefficients were the same number, they would already cancel out. So I'm going to multiply this entire top equation by 3 and the entire second equation by 4. Now, you have to remember to also multiply the other side of the equation by 3 and 4. So sometimes I write that over there so I don't forget. So 3 times 5x is 15x. 3 times 4y is 12y. And 3 times negative 83 is negative 249. Now I'll do the second equation. 4 times 3 is 12x. 4 times negative 3y is negative 12y. And 4 times negative 12 is negative 48. Now I'm going to combine them together, or add them, if you will. So you're going to do, you're combining them. So sometimes you might be adding them if they're both positive or both are negative, or you could be subtracting them if you have different signs. So don't just think that, oh, you have to add all these numbers together. It depends on their sign. You're combining them, okay, following integer rules. So these make a zero pair, which is, exactly what I wanted. So that's good. And now 15x's and 12x's together give me 27x's. Negative 249 and negative 8 together gives me, let's see, 9 and 8 is 17, that's 9, 297. When you then divide this, you are going to get x equals negative 11, I believe. So it's going to be negative 27 goes in 29 once with a remainder 2, so it goes in once again. So x equals negative 11. Now I'm going to go back to one of my original equations, and I'm going to choose to use this one, only because I don't want to deal with negative 83 for whatever reason. Negative 12 seems easier to me. I'm going to put in x equals negative 11 instead of the x there. So I'm going to do 3 times negative 11 minus 3y equals negative 12. Okay, I'm using the original equation there. So negative 33 minus 3y equals negative 12. So negative 3y equals, let's see, 21. I added 33 to both sides. Divide by negative 3, and I get y equals negative 7. Okay, so the ordered pair for this solution is negative 11, comma, negative 7. Okay, this part is where you are writing equations, and then you can solve them any way you want. You could graph the system. You could do substitution. You could do elimination. You could even make a table and guess and check. The important part about this section is, do you know how to write the equation for a situation that involves a system? Okay, so if it involves a system, remember, that means you have two different equations using the same variables. So that means they're giving you some situation, like in number 4, you have nickels and quarters. So you have some coins, and you know 2 pieces of information about them. So we know how many coins we have altogether, and we know how much money it equals altogether, okay? So the first thing I'm going to do is, of course, define my variables. So I'm going to let n equal nickels and q equal quarters. Okay, and then it says we have 47 coins. So n plus q equals 47. And they're worth $6.35. So this is where you put in what a nickel and a quarter is worth. A nickel is worth, I write it over here so I have more room, 5 cents. So that's 0.05 nickels. plus 0.25 cents for a quarter, and together that adds up, equals $6.35, okay? That is one equation you could write there. But all of these decimal points and zeros, when I try to solve this, I don't like all the decimal places. So I'm gonna go through and multiply everything by 100. So the other equation I'm gonna use is 5n plus 25q equals, I'm out of room, hang on. There we go. 635. Okay, so normally I would do elimination, but I don't want to multiply 47 by anything. So I am really going to use substitution here. But let me go get another page. I don't know if I can add another page here. I think I tried that once before and it didn't work. So how much room do I have down? Okay, I'm just going to scooch up like this here. All right, so we have n plus q equals 47. And then 5n plus 25q equals 635. All right, so I'm going to go ahead and take this equation and solve it for n. So 47 minus q. And then I'm going to put that in instead of the n to do a substitution. Write down the rest of my equation. Now I have an equation just with q, so this is going to tell me how many quarters I have. Oh, so I still have to do 5 times 47. Okay, 5 times 47, 7 times 5 is 35, so 235 minus 5q plus 25q equals 635. Combine like terms, and I get 20q here. 35. And then, go that first. Then I subtract 235 from both sides, and I get 400, divide by 20, and it looks like I have 20 quarters. So if I have 20 quarters, and I have a total of 47 altogether, that must mean I have 27 nickels. Okay, so I really substituted the 20 for the q back into this equation here. But I think, if you guys know they add up to 47 and you have 20, I'm pretty sure y'all can come up with 27. Okay, so let's go up here and write my answer. Okay. There we go. So, nickels are 27, quarters were 20. All right, so moving to the next one. A contestant on a quiz show gets 150 points for every correct answer and loses 250 points for each incorrect answer. Okay, so we have a situation where we have correct answers and incorrect answers. Okay, after 20 questions, so we have a total number of questions, and we have the fact that they're worth 200 points in the end. So our first thing we're going to do is define a variable. I'm just going to say let x equal correct and y equal incorrect. All right, so the correct questions combined with the incorrect questions have to add up to 20 since there were 20 questions. And then I gain 150 points for the correct question, but lose, so minus 250 points for the incorrect questions, for when I'm all done, a total of 200 points. Okay, so I'm going to, again, use substitution. I'm going to solve x plus y equals 20, maybe for y. So y equals 20 minus x. Then I'm going to put that in for y right there. Okay, so again, I'm going to kind of go find some room down here to work. So plus y equals 20, so that's right. I did y equals 20 minus x. Okay, so then 150x minus 250, instead of y, we're writing 20 minus x, has to equal 200 points. 250 times 20 is, I'm sorry, 0, 10, yeah, 5,000. Was doubting myself there for a moment. Plus 250x equals 200. So 150 plus 250 is 400. And 5,000 plus 200 is 5,200. And give me some more room here. Divide by 400. That's the same as dividing 52 by 4. So x is 13. So they answered 13 questions correctly, and they answered 20 questions in all, so 7 questions incorrectly. Let's go back here and write our answer. So x is, oops, I want to use black so you can see it. X is 13, y is 7. Okay. All right, so the next one, I don't know why this was difficult for a lot of people. I'm not sure why. This is exactly, you wrote equations for a situation like this in when you did 8th grade math. We just didn't necessarily call it a system. It was a question where, like, company A charges this much plus that much an hour, and company B just charges this much an hour. At what point will the companies be the same? And you wrote an equation with variables on both sides and solved it. That was a system. So it's the same thing here, okay? So if I look at my question, it tells me my variables are years and songs. So I'm going to say, let x equal years, since that's independent because it's time, and y equals songs. So if I look at what Jay is doing, he already has 24 songs, and now he's writing 6 songs per year. So Jay's total number of songs is the 24 he started with, plus the 6 he writes every year. Jenna hasn't written any songs. She just started, but she's going to do 12 songs a year. So Jenna's total songs will be the 12 songs for each year she writes them, because she's starting with 0. Okay, so those are your 2 equations. Let me write them over here. 24 plus 6x and y equals 12x. So I'm going to solve this by really substitution. I'm going to put this in for that y. So, and it says, how many years from now will Jenna have written as many songs as Jay? So, like, when will they be equal? Well, we can find that out by setting them equal. Subtract 6x from both sides, and you get 24 equals 6x. Divide by 6, and x equals 4. Okay, so the question just asked, how many years from now? So that would be 4 years. The ordered pair then, y would be 48. So after 4 years, they both will have written 48 songs. But we only need that one. Okay, so number 7, without solving. Now, I know it says without solving, but you do have to do a little bit of something here. Tell whether the system has no solution, one solution, or many solutions, and then, of course, explain. Okay, so if you kind of rearrange this a little bit, or, I mean, that's what I did, but I do remember some people telling me this is just scaled up. So if I look at this is just, if I multiply everything by 2, I get 2y equals 6x minus 22. And when I bring the 6x over there, I get 2y minus 6x equals 22. So I didn't solve it, I just rearranged it. And look, it is exactly, I'm sorry, negative 22. It's exactly the same equation. So it has infinitely many solutions because it's the same line. Okay, so you needed to say that. Some people told me, same line, so no solution. No solution would be, they're parallel. Okay, and then some people did tell me no solution because they have the same slope. That's true, but they also have the same y-intercept, which makes it the same line. Okay, finally, the last part, inequalities. Okay, and I think we did, like I said, the best on this because it was so recent. So 8 and 9, the first thing you have to remember when you're graphing inequality, first of all, you need a line and you need to decide whether it's dashed or solid. And the second thing you need is shading. Okay, before you can graph the line though, you need it to be in slope-intercept form. So unless you want to, choose some points for x and y, but that's a lot more complicated. So solve this for y first. So I'm going to add x to both sides, and that is inequality I'm graphing. So I start at 3 for my y-intercept, and then I count my slope, positive 1. Okay, up 1 over 1, and it's going to be here. And now I have to decide what kind of line, dashed or solid. It has that also equal to part, so it is going to be, hang on, let me move a little bit. It's going to be a solid line, so like this. Now I need to know whether to shade above or below. When I look at that, I see that it says less than, y is less than. To me, that says below. But remember, if you are not sure, you pick a test point. So the origin is nice and on definitely one side of that line. So I'm going to use that. So is 0 less than or equal to 0 plus 3? 0 is in fact less than 3, so that's true. So that's where my shading goes. So you need to shade under here. Okay, and don't have to be perfect. All right, so that's that one. Now let's look at number 9. Again, I have to solve for y. So I'm going to subtract 6x from both sides. And then I have to divide by 2. So y is greater than negative 3x minus 1. Okay, minus. There's a 1 there. Okay, so I'm starting at negative 1. Right there. And then my slope has to be negative 3. Had a lot of people draw me a positive slope. Negative 3 means down 3, 1, 2, 3, to the right 1. Or up 3, 1, 2, 3, to the left 1. Okay, now I look to see what kind of line I need. 2, 3, 1. And it is dotted because there's no also equal to. So just put a dotted or dashed line in there. And decide where to shade. It says greater than, so in my mind it's above, and I clearly see one side of the line is above. But if you are not sure, you can check a test point. Now that does not go through the origin, but since I can't really see it because my line is not real great, I'm going to choose this point right here. Looks like I'm choosing 3, 3. All right, so is 3, let me write the ordered pair here so you know where I'm getting the numbers from. Is 3 greater than negative 3 times 3 minus 1? So, is 3 greater than negative 9 minus 1? Yes, 3 is greater than negative 10. So that's true, so that's where my shading goes on this side. Okay? Okay. Number 10. All right, so number 10 is already graphed for us, but when you look at the inequality, it's not solved for y. So you really can't just say, oh, it should be less than, so it has to be shaded below. You really can't tell anything about the slope or the y-intercept. Actually, I don't think the y-intercept matters. If I look at these, they all have a y-intercept of positive 2, so that's not going to help us. They're all also solid lines, so that's not going to help us. Okay, but I see I have some positive slopes and some negative slopes. But before I do anything, I really have to solve this for y, so I know what I'm working with. So I'm going to subtract 4x from both sides. And then I have to divide, oh, that's a y. That looks like a g. Let me fix. And I have to divide by -8, everything. So remember, when I divide by a negative, I flip this sign there around. Okay, -4 divided by -8 is positive 1/2. And there's my +2 for my y-intercept. So the first thing I'm going to look at is this slope is positive. So I'm going to come over here. I'm going to cross out any slopes that are negative. This one is a nice negative slope going down. So it can't be C. Oops. And that's, let's see, this one is positive, so it could be that one. This one is negative, it's going down, so it's not B. That's positive, so it could be that one. So then the next thing I look at is my, oh, geez, I keep drawing on this. I am sorry. I look at my inequality sign. It says greater than, so it needs to be shaded above the line. Well, to me, A looks like above and D looks like below, so I would make my choice based on that. But if you're not sure, let's check a test point. So the origin is here. So in the shaded part, or the origin is here outside the shaded part. So we're going to use the origin and see if we get a true statement or a false statement, and that will tell us whether it's A or D. So is 0 greater than or equal to 1/2 times 0 plus 2? So is 0 greater than or equal to 0 plus 2? 0 is not greater than 2, so it can't be in the shaded part. This is false. So it doesn't get shaded on that side of the line, so the correct answer is A. Okay, so this last one, or the last couple, last page. Graph the system of inequalities. All right, so this one's already solved for y, the first one. So I'm going to just start there at y-intercept of 3. So 1, 2, 3. There we go. And I need a negative slope, -1. So down 1 over 1, down 1 over 1, down 1 over 1, up 1 to the left 1, up 1 to the left 1. And I see that it should be dotted or dashed because there's no also equal to. So I'm going to put that in right there. Now the shading, it says greater than, so that's above. But again, I see right here my origin is nice and clear. Clearly on one side of the line, so I'm going to use it. Is 0 greater than -0 plus 3? So is 0 greater than 3? No. So it does not get shaded on that side of the line. It gets shaded on this side of the line. Okay? All right, now let's look at the next equation. You need to solve this for y, but oh, geez Louise, so sorry. Hang on. Getting all excited here. There we go. All you really need to do is move the 2x over, add 2x to both sides. So that's your other equation. All right, so -1. And now I'm going to go up 2 over 1 for a positive slope of 2, down 2 over 1. You know, I think the points do intersect there. Someone told me that, but these are inequalities. So the solution of the system of inequalities is not the point where they intersect. It's where that shading intersects, because there are still a whole bunch of solutions for these. All right, so that's less than or equal to, so that's going to be a solid line. There we go. Now I have to figure out where to shade. Again, my origin, this time I'll use red, is clearly on that side of the line, so I'm going to use it for here. So is 0 less than or equal to 2 times 0 minus 1? Is 0 less than or equal to 0 minus 1? Is 0 less than or equal to -1? No, that's crazy. 0 is greater than it. So it's not being shaded on that side of the line. It's being shaded on this side. Okay. All right, so your answer should be, let me get my purple here, this section in here. That's where the blue and the red overlap. Okay, so on your test, you would have needed to make that darker, and then some people wrote in there that it's right here. So something like that is fine, so that, oh, again, with the highlighter, I could see. All right, so the next one already has it done for you. Which system is graphed? And okay, it's the end of the test. I get you're tired. All of these are in standard form. So, I'm trying to think of what you could do. You could take your origin, right here, substitute it into all of these and find the one where both equations are true with a 0 in it. For example, in A, 0 is greater than 3? No, because this would be 0, this would be 0, so that can't be A. So you could do that if you didn't feel like going through the whole thing. But you know, I love to do these, so I'm going to go through and do it the other way, where I'm going to put, solve all of these for y, and see what I get. So here I have y is greater than negative 2x plus 3. I'm going to go and see if that line is graphed. So here's my plus 3, negative 2, down 2 over 1. It looks like that's that line, so that's good. It says greater than, but, okay. I'm sorry, what was I saying? Someone came in. Okay, wait. All right, so that says greater than, but I see that that line is shaded like over here, which is less than, so it can't be A for that reason. All right, now I need to kind of erase this stuff here. All right, so moving on to letter B. B, let's see, this is y is greater than or equal to negative x minus 2. So let's see if that's graphed correctly. That's negative 2. It is a solid line, but this is a positive slope, and that's supposed to be negative slope, so it's not B. So C, so you have y is greater than x minus 2. Well, that's the wrong kind of line. This is the right y-intercept. It is the correct slope, but this is a solid line. That should be dashed. That means it better be D, since that's the only one I have left. So y is greater than or equal to x minus 2. That's this line here. And it's greater than, so it is shaded above. That checks out. This should be y is less than negative 2x plus 3. And that's this line, and it's dotted, and it is shaded below. So that also checks out. So D is the correct answer. Okay, now if you're saying to yourself, what in the world, why did you not just use 0, 0? Let me show you that. If I put 0 in here, 0 plus 0, 0 is greater than negative 2, true. 0, 0 is less than 3, true. Okay, so there you go. And just one more, if 0 plus 0 is greater than negative 2, that's true. But 0 minus 0, oh, wait a minute. Wait. That works. Why does that work? Wait a minute. What happened here? 0 is greater than negative 2. 0 is less than 3. Oh. Maybe you better not do it that way. I guess you should do it my way and go the long way, because that one worked out. I got to think about that a little more. But definitely, once you get the answer, I'm erasing all this here. I guess I shouldn't be. Once you get the answer, go ahead and double check some of the points that are in there. That's true, that's true. But that is interesting. That one also is true. Huh. But the lines aren't graphed right. That slope is not correct. Okay, so the last question. What I had intended it to say is, look at the one we just did, like number 12. Oops, sorry, 12. Pick a point in the solution set. So any point in that dark gray area, so like 0, 0. And why did I choose it? Well, because it made both of these true, or a lot of people said because it's in the double shaded region, that means it makes both of them true. So something along those lines. Okay, so same thing. If you didn't know that and you came up here, you would just need to say something about picking a point in this area, like this one or this one or this one. And say why, because it makes them true, or it's in the double shaded area, so I know they're true, something like that. All right, so test corrections. Should have started with this. You have written them out, and then, you know, you do need to go back and reflect a little bit and like, what did you do wrong so that you learn? If you need to come in, you watch this and you're still not sure, then come on in for tutoring. I'll have the times posted in the classroom, like the physical classroom on the yellow doors, not, well, I guess we can put them in the Google Classroom as well. And then as soon as you're ready, let me know, and we'll do your retest, okay? So check the schedule for those dates. Okay,